Alright, this is going to be our video tutorial on our one-dimensional motion video test, which is our first of many, of course, for these unit video tests. I'm going to go through, of course, the objectives, my expectations for you guys, and then I'll actually model what it should look like with the video that I actually did. So you guys can read this on your own time, but of course the main thing is in the purpose. For this, make sure it's an object moving in just one dimension, so not two yet, we'll get there. But it has to have a uniform acceleration other than zero. Alright, zero would mean it's a constant velocity, which is not the goal of this. When you get to the procedure, you'll see a detail is it can't be an exact duplicate of something we've done in class. So I'm talking exact same object, exact same setup. So you might be able to use a tennis ball as an object, but you can't do exactly what we did with it in terms of just dropping it or throwing it up like the free fall lab. Okay? When you do figure out what you're going to do, you're going to then shoot it with video physics and use graphical analysis to, of course, analyze it. You're going to create a screen recording like what I'm going to do in a moment. And then, of course, if you need help with that, I've got some links down there. Something kind of fun if you look halfway. I want to make it an interesting thing for us, kind of fun, so I added a creativity wins points. If you guys can come up with a unique scenario that's kind of fun, I'll give you a bonus 2 points. This is subjective though, so it's kind of just up to me if it is a unique idea. Alright? You'll notice then the objectives for this are all listed there. There's 6 of them. But of course they're kind of vague. I didn't want to get too wordy, so I'll add stuff to it like, hey, this should be explained in the video as well. You'll also notice for points, as long as you gave it an attempt, so not the no attempt. If you tried, the worst you can do is a 3 out of 5. Probably not the best score, you probably want better, but it's not going to completely crush you as long as you gave it an attempt. I'll also tell you this is not necessarily the order you need to cover this stuff in. For instance, I'm actually going to talk about the displacement, velocity, and acceleration with the dot diagram, the data point picture, all at once. So I'm going to hit objectives 2, 3, and 5 first, at least after I talk about the video. Okay? So of course it's due Sunday night to give you some time over the weekend. And again, have fun and take your time to make sure you really understand what's going on and explain it clearly. You can definitely do as many takes as you need to. That's why I think this will be kind of fun. Alright, so here we go. I'm going to model what it looks like for you guys. And of course, I'll kind of have moments where I pause out of the actual test portion and I'll say, this is what you should do, or maybe show this as well, okay? So always start off with, sorry, it's late at night, so I'm kind of in my bedroom. But always start off with, number 1, look at the camera. All right, not the screen, but start off with introducing yourself. So I'm going to start off by saying, hello, this is Mr. Bang, and this is my one-dimensional motion video project, video test, excuse me. The video is going to be an object that has uniform acceleration in one component, one dimension. All right, to start off, I'm going to show you guys the video. So then you can jump over, of course, to the video. And you can probably just play the video without talking too much at the beginning. So this was fun. It's kind of near where I live on the south side of the zoo. So I'd like to let you guys know a little bit more about me as we go through the year. And what I might do as well right away, even though it's not on the objectives, is I might, just to make sure Mr. Bank knows that it's legit, I might then show you, okay, there's my scale. I was a little bit of a weirdo in the park that day. I was holding a half-meter stick, so that's why it's a half-meter stick. That's what that is. And you'll also notice I'm going to focus on the x-axis, so I had to actually tilt it because I'm on a little bridge that's an incline, a hill. So you can see I'm only going to look at the x-axis, which is slightly adjusted to be in the same direction as the data points. All right. You could try to state a simple conceptual understanding on uniform acceleration by saying, well, in the video, if I back up, as I went up the hill, I slowed down, so changing velocity, and then when I went down the hill, I sped up, so again, changing velocity. So I definitely know I have an acceleration. I probably can't answer confidently if it's uniform until I get to the graphs. So I probably won't cover that first objective perfectly until I actually get to the very end. But anyway, what I'm going to do right now is I'm going to talk about the displacement, velocity, and acceleration with the data points. So It's going to be easiest because I chose a really tough scenario where data points overlap because I'm coming back on the same path I started. I'm actually going to talk about the positions, which are the data points. I'm going to talk about them as the video plays. What I need to also point out is, based on my origin, that I still have the positive x to the right. So I decided to choose a scenario that I typically did not recommend to you guys. To the left of my screen is the negative, to the right is positive. So I'm actually making it a little bit harder for myself. So you guys might want to do an object moving to the right or moving up if you do something in the y component with free fall. Okay, so you're going to hear me explain this a lot with negative and positives because I made it tricky. But anyway, here we go, excuse me. All right, as I go up the hill, you'll see that my positions and the changes in them get closer together. So my displacement is actually becoming less. And then as I go back down, it then gets further apart and actually becomes larger. All right, because to the left is negative, my displacements actually at the beginning become less negative. So that's a tricky thing. As I come back down the hill, they actually become more positive because I'm then moving to the right. So then to piggyback off of that idea, when I'm going up the hill, I do have a negative velocity because I'm moving to the left, but because the displacements get smaller, it's becoming less negative. When I then go down the hill, my displacements are now to the right, so I should have a positive velocity, and they're getting larger, so my velocity should now be becoming more positive. All right, so up the hill, I had negative velocities that basically got smaller, became less negative, and down the hill, I was moving in the positive direction, so positive velocity, and the displacements got larger, so my velocity became more positive. Now, acceleration with this idea is a bit tricky, but basically, I do have an acceleration. All right, might be easiest to just start off by saying, I definitely know I have an acceleration because my displacement is changing. What my exact acceleration is, I might use with the graph. I might explain it better with the graph. So you could probably even do the same for velocity. You could tell me which way your velocity is and basically say it's changing, and you might use the graph to be a little bit clearer with that, okay? So the dot diagram, though, I want you to understand displacement changes, and if it does, then velocity is changing, and maybe what are your velocities and how is it changing? And then the general idea, if you do have changing velocities because of the displacement changing, you definitely have an acceleration. All right, so I've covered quite a few of the objectives there pretty quick with the picture. And now I'm, of course, going to export it, which I already did, so let's save time. And I could just go straight to the graph. What I could also do, though, which is kind of cool, we talked about this earlier, which actually I'm going to have to open them up separately, so give me a second. If I have this on my bottom taskbar and this on my bottom taskbar, I should be able to open up simultaneously the video. All right, sorry, not like that. Split screen, you got to actually hold it and then drag over here. So this might be useful to you guys to actually have this side by side. If it's not, that's fine, don't use it. All right, and clearly right now you can see I'm having some tech issues with video physics actually showing up. All right, I lied, it's there. But you can see it's not showing everything, so I don't know, maybe that won't help, and maybe you just want to go full screen with the graphical analysis. Your call, use multiple attempts. All right, here we go. I'm going to hit the other two major objectives, though, with describing velocity and acceleration with my velocity versus time graph on the bottom. You can talk about position up here in the top graph. You could honestly just kind of drag this guy around and be like, hey, my position is clearly changing when I move this around. And if it kind of tries to highlight, that's okay. But you can see I can move it around and say, okay, at different locations I have these positions. All right, so I have a different position clearly. You could also add the slope of a position versus time graph represents velocity. And this slope is definitely changing, so I clearly have changing velocities, which means I have an acceleration. I'm going to do a lot of my explanation, though, with the bottom graph. So here we go to meet those two objectives. I'm going to just talk about velocity to start. So if I go to the beginning, this confirms what I was saying with direction. If you just look at the data point at this time of 5.4 seconds, the beginning, I have a negative velocity because I was moving to the left. As I progress up the hill, I'm still moving in the negative direction. And the slope of this is not representing the hill. All right, I know that I'm going up the hill though because I'm still moving in the negative direction. I have a negative velocity of 0.81, which is to the left of my video up the hill. My velocity though became less, at least in terms of the magnitude. All right, so my velocity is changing, and if I keep dragging this up, it's kind of cool as it's becoming less and less negative. And when I get to the peak, it actually kind of paused for a moment and I had a velocity of 0. All right, it continues to change though, because now I'm moving down the hill. I'm moving down the hill because I now have a positive velocity of 0.401 meters per second, which to the right of my screen was positive, and that was down the hill. This continues though as I progress to become more positive. So I definitely am still changing my velocity all the way until the end. All right. So that is how I would describe velocity. You might not really be talking in a kind of tutorial way like I was, but I can honestly just drag it to different data points and say, all right, here's the velocity I started with, here's how it's changing. All right. Now let's talk about the big thing, acceleration. Okay. Well, good news is we've been talking about velocity versus time graphs, and we know that the acceleration can be figured out from the slope because it would then be rise, which is change in velocity, over run, which is change in time. To do this, really simple, keep that tool open, but grab the big data point or big box, and then basically just highlight the portion you want. This wasn't a perfect scenario. There might have been a little bumpiness on this hill, and my data points might have been a little off, so this isn't looking perfectly linear, but it's close. So I'm actually going to curve fit it, and I'm going to say that my slope, m, is telling me my acceleration, and it is 0.312 meters per second squared. Now, you have to tell me what that means in terms of velocity, so it might be easier for you to say, my acceleration is positive 0.312 meters per second each second. And what that means is no matter whether I have a velocity in the negative direction or positive direction, it tells me that my velocity will change by that amount every second. So no matter which way I'm moving, my velocity is going to change by a positive 0.312 meter per second value each second. Okay? The last part to that then, which was our first objective in the actual write-up for the lab, is it uniform? Well, uniform acceleration means those changes in velocity are occurring by the same amount. I know it's uniform because my graph on the velocity versus time graph, my data is fairly linear. So linear confirms that these velocities are changing by a constant amount, and that's a better way for me to confirm that it is a uniform acceleration. All right. So I didn't do the best of course, telling you exactly how it would look on your end, of course, with the video. I kind of talked mix, almost explaining what the objectives are. But I will want to add this, and because we're grading these, they do need to be kind of more brief and concise than what mine was. So I want you guys to be thorough with your descriptions, but of course be more direct and to the point with these objectives. Probably a general rule, we'll see how it goes, but I'm thinking it probably definitely under 5 minutes. All right, I would not go above that because it would just take way too long for us to grade. All right, if you can get to the point in 3 minutes and you feel good about covering all of these, awesome. All right, and if you feel like you can explain it perfectly with one thing, like one quick explanation, that's great. You don't have to be as redundant as I was. I was just kind of telling you how I could describe it a couple different ways, okay? All right, I hope this helps, guys. Again, have fun with this. This is a chance for you to assess to see if you were learning physics along with the tech we're using. And I also want it to be fun, so hopefully you can have some fun with it. Get outside if you want to, do something outside like I did. It might even show me like hobbies you're into as well. If you play some sports, maybe you can factor that in. That'd be kind of cool to see. All right, guys, good luck.